This time, for number 3, I've decided to ignore, in a sense, the book's instructions to plot just a single vector and a single level set for a function. So instead, I'm going to say that the gradient of y minus x squared is negative 2x, the derivative of this thing with respect to x, in the first component, and 1 in the second component, the derivative with respect to y. And that, my friends, is a function. It is a function that assigns to every point in the plane a vector. And I'm going to draw that below along with the level sets of the function y minus x squared. So the sets of ordered pairs x, y such that y minus x squared is equal to c. I'm going to name, oh wait a minute, who's getting named here? The LC is getting named this. Okay, so LC is the level set corresponding to C. Now, I can very easily see that L0, the level set corresponding to 0, is the solution set to y is equal to x squared. That's the usual parabola here. And let's see, L1 would be the solution set to y is equal to x squared plus 1. That'll just look like this. L1 and L2 will simply be the same parabola lift it up a little bit more, L2, and I could go on, but I'm going to go the other direction. I think that it's clear that L negative 1 is right there, and L negative 2 about right there. Okay, so I've drawn several level sets, and you can imagine what other ones would look like. We keep getting parabolas going lower and lower, and the sets the level sets fill up the entire domain of this function y minus x squared, which of course is the entire xy plane. And now in red, I would like to draw this object. It is a function that assigns to every point on the plane a vector. So let me think about this for a second. Where would it be easy to evaluate that function? First of all, it'd be really easy to evaluate it where x is 0. X is 0, that's along this line. Okay, so anywhere along there, this vector should be 0. So let's see, right here at 0, 0, for instance, the vector points 1 up and not at all to the side, right? So that is the vector right there, 0, 1. And similarly, at the point positive, so 0, positive 1, the point 0, 1, right there, the vector field has the same value. See, this vector function has the same value, and so this is 0, 1 also, starting at a different point, right? That's the point 0, 0 right there, and that's the point 0, 1 right there. And even at the point 0, 2, the vector function points straight up to give us another 0, 1. Okay. Where else would it be easy to evaluate that function? Well, of course, down here and down here. Let's see. I'm going to go out to the right, 1 tick mark. Do I want to do that? I don't know. It looks dangerous to me. I'm just thinking about what the drawing is going to look like. It's going to be difficult to draw. Okay, so I'm going to go out to the right, 1 tick mark. And will that put me here? Yes, right. So y minus x squared is equal to negative 1 indeed has the point 1, 0 as a solution, doesn't it? Right, for L negative 1, let's see, we have 0 minus 1 squared is negative 1. So yeah, that point right there is indeed on L negative 1. And let me try to figure out what this function looks like there. The components should be negative 2 times 1 comma 1. Okay, so I need to draw that vector emanating from this point. So it's going to go up 1, it's going to go up to there, and then it's going to go over 2, over to here, and then there's 2. So it's got to go over that far. That means, okay, I have to draw a vector from here to here. Okay, so that is the vector emanating from this point. See why I was hesitant to draw that one? It gets all murky. I have the vector negative 2, 1 emanating from the point 1, 0. And again, you see that this is orthogonal to the line tangent to that level set, just like this was orthogonal. So the direction of my gradient vectors is going to change as I change where I am on the plane. And maybe this isn't the best to draw that, but you know what I'm going to do? Just to help visualize this, I'm not going to be so rigorous about the lengths anymore. Let me just draw the directions that I would have associated with the gradient everywhere. That would look like this. Right? Orthogonal to the surface. Okay. Orthogonal to the level sets everywhere. And I'm not drawing lines or vectors of the proper length. I'm drawing instead just the directions. Okay, this is the kind of object, the object in red here, this function, that's the kind of object you'll study extensively in 21D and that you need to start wrapping your head around now. A function that assigns to every point on the plane a vector. And can you see how it's being done in this case? The vector that we assign to a point on the plane depends only on its x value. As we move over to the right and increase x values, we're getting bigger negative first components, and hence we're getting really long vectors pointing to the left. And then over here, as we go to the left, negative x values that are way out there will get large first components, and we'll have vectors that point off to the right. Okay, I hope you got a lot out of that conversation, because, well, it was just fun.